Hi all, myself Deepika from the Department of Radiography and Imaging Technology from SNS College of Allied Health Sciences. Now we are going to discuss about X-ray production and X-ray tube design. So here comes the discovery of X-rays. X-rays were discovered by W.C. Rontgen in the year of 1895 on November 8th when he was investigating the conduction of electricity through gases at low pressure in glass tubes, and suddenly he noticed a positive electrodes in the tube. He gave some invisible rays, and since the nature of the rays was not known, he named that as X-rays. So next comes the properties of X-rays. X-rays are electromagnetic radiation of shorter wavelength, and they travel in straight line with a velocity equal to light. And X-rays will not be influenced by electric and magnetic fields, and it produces fluorescence on materials like calcium sulfate, zinc, cadmium sulfate, and etc. And it can also affect the photographic film and form latent image. X-rays will produce ionization and excitations, and it produces chemical changes in certain substances, and X-rays can have biological changes in human living organisms. So production of X-rays. X-rays are produced when fast moving electrons are stopped by means of target material. So the moving electron possesses kinetic energy, and this kinetic energy is converted into heat and X-rays. This conversion is taking place in the target material, which is anode, and therefore the interaction of electron is the first basis for X-ray production. And here comes the characteristic X-rays. So how the characteristic X-rays are produced? Characteristic X-rays are produced by interaction between the incident electron and the electron in the case shell. So in this process, the incident electrons will be directly interacting the case shell, case shell, and transfer sufficient energy and removes the case shell electron. The vacancy in the case shell is filled by the electron moving from the outer shell to the inner shell, and during this transition the difference in binding energy of these two shells will give off some rays known as X-rays, and this photon is known as characteristic X-ray. Next comes the Bremsstrahlung X-rays. The incident electron will be occasionally reaches the nucleus of an atom in the target. So since the electron is negative particle and it is attracted by the positive nucleus, it is made to orbit partially around the nucleus, decelerates, and goes out with reduced energy. The loss of energy appears in the form of X-ray photons known as Bremsstrahlung X-rays. Next comes the X-ray tube design. So the production of X-ray needs a certain components known as electron source, which acts as an cathode, target to stop the electron, which is anode, and high voltage supply to accelerate electrons, vacuum, and tube insert. The next is cathode. Yes, cathode is a tungsten wire in the form of helical filament and surrounded by a focusing cup. The tungsten is used in the filament material because it has high melting point, low vapor pressure, good ductility, and low work function. So because of these properties of the tungsten, we are using tungsten as a target material as well as the filament. The function of the focusing cup controls the width of the electron distribution and directs the electrons towards the target, which is anode. Space charge effect. When the applied KVP is zero or small, like KVP is zero or small, the electron surrounding the filament forms a cloud, resulting in space charge effect. So these electrons tend to repel the electron back to the filament, and hence the tube current is very small. So when the KVP is increased, the effect of the space charge reduces gradually, and the tube current also increases. So this is known as space charge limited region. The next is anode. Anode is a target we use in the X-ray tube, which is maintained at a positive potential. We use tungsten as an anode. As I already discussed, the properties of tungsten is high melting point, high atomic number, high thermal conductivity, low vapor pressure, and easily machined to make smooth surface. Focal spot size. Focal spot is the area where the electrons hit and the X-rays are produced. So the area of the target within which the electrons are observed and the X-rays are produced is known as focal spot or focal area. If the focal area is very small, penumbra will be lesser and the picture sharpness will be good, but heat removal is difficult. On the other hand, if the focal spot is large, heat removal is very happen very quickly, and the penumbra will be large and the picture sharpness is bad. So we have to compromise in this, and we have to design the X-ray tube with the help of line focus principle. So line focus principle, in the sense, the X-ray tube requires a specialized focal area in the target, which is larger in size to spread the heat easily and smaller in size to act as a point source. So the point source reduces penumbra effect, resulting in sharp image. Hence, the target of the X-ray tube is mounted at a very steep angle with respect to the motion of incident electrons. The X-rays will appear to come from small focal area, which is known as effective focal, and the X-rays will come from large focal area, which is known as actual focus. So this is known as line focus principle. Anode angle, in the sense, the angle of the target surface when the anode side is known as anode angle. And here comes the assessment for the students who, the first is who discovered X-rays, mentioned any five properties of X-rays, mentioned the function of focusing cup, line focus principle, and the space charge effect. uh, in the end, we are going to see about tube insert, housing, and vacuum. The tube insert or envelope is made up of borosilicate, a glass window, and it contains a vacuum which supports the electrodes. The tube insert serves the following purpose. The purpose of the tube insert is it observes the X-rays emerging in undesired directions, maintains required vacuum, and acts as an electrical insulator. Contains cooling systems which removes the heat and the in the target surface. So glass is susceptible to damage from the electron. So glass is there to protect the X-ray tube from the damage, and the metal envelope have been developed with low attenuation beryllium window for X-ray transmission. Uh, High vacuum will be maintained inside the X-ray tube in order to avoid the collision between the electrons and the gas molecules, which give rise to ionizations that reduces the kinetic energy of the electron. Tube cooling is mandatory in the X-ray tube, and the tube cooling is necessary because only 1% of X-ray will be produced, and the maximum of 98 to 99% of heat will be produced. In order to avoid that heat, and which will damage the X-ray tube, heat tube cooling is necessary. So efficient cooling system should be maintained. Thank you.